That's good. That's good. That's good.
You are now muted. You are
Let's
now
just wait
unmuted.
a few seconds so that others can successfully join, and we start our lecture.
You are now muted.
It's okay, see. But tika silence boy.
You are now unmuted.
Silence boba tutofara so tutofaya takamira.
You are now muted.
Zonyanya manje kare. Vari maskambotanga so.
Bananzwe.
You are now unmuted.
Right, I think we now have a good number. Let's start our lecture. I will try by all means to have this lecture as short as it can, so that I do not waste much of your time, so that you go and do your assignments and all other stuff that you may do by yourselves. Right. I will share the course outline through the class rep, that is Arnold, if not mistaken. And I'm happy that I'm having Arnold in this lecture. I don't know if I was having him in the previous lecture that we did in the morning today. So let's begin. So course outline, I will send it through Arnold. The assignments, I will send them all through Arnold, but keep on checking your portal. I'm observing that I'm having no one registered for these two modules, so please make sure that you register your modules and be available on the portal, because I keep on posting things on portal. I keep on posting things on portal because that's the formal communication that we have, or that we use at CAT. So I will be posting stuff there. Right, so this module is all about let me share my screen before we start all these things. Why is it that I'm having only Only four participants. Where are others? Where are others? Where are they? Right, I'm here. Can you see my screen right now? Please confirm. Are you seeing my screen? Let me check. Yes, Wayne is seeing it. Okay, that's fine. So let me run this thing. Like I said earlier in the previous lecture, I do upload my video tutorials on the channel named Shexa, the IT guy, also named as Engineer Shexa. So you'll find all the content or some of the content uploaded on this channel. So today in this lecture we're covering computer graphics and multimedia, but it's just an introductory lecture. We'll talk about what computer graphics is, what is multimedia, computer graphics, and multimedia applications. So that's what we shall be talking about. But before we talk about all these things, may I get what you expect? What are you expecting to learn from this module? What are you expecting to learn from this module? Let's talk. Let's have a small discussion. Those that can use their mics, please unmute yourselves and say something. What do you expect to learn from this module? Computer graphics.
Ray tracing is
Sorry?
ray tracing unoshandiswa magame yeah.
Okay. Arnold?
Ndineklusa.
Matiba. Arnold, andaunza zvoda.
Okay, ndati handina clue.
Oh, you have no clue, mom. Don't dzidza chero zvamadzidziso. Anyone else atitaurirawo zvaari kuexpecta? Ashwood, what are you expecting to learn from this module? Avatiza Ashwood, manaka. Tell us what ndambotaura nini.
Yeah, I think like it's like
Animations. Alright. I'm yet to know what you are expecting to learn from this module. I'm yet to know what you're expecting to learn from this module. So before we talk about all those things, I will just give you an introduction of what computer graphics is. I will tell you what computer graphics is, but before I tell you all about computer graphics, I'm happy that some of you are already interested in learning 3D animations. Although you just said animations, I'm sure that you like the most modern way of animating things. So the most the top or the most popular one is 3D animations. That's what we'll be focusing on mostly. But before we do this, we need to know the best hardware that we need to use. We need to know a lot of things before we start to do all those things. And for you to come up with a proper 3D animation, you just need to know three things, and we will talk about those three things. And that's what that makes the basis of your computer graphics and multimedia. And later on, as computer engineers, you need to learn programming so that you tailor make the applications that enables people or audience or anyone who uses these applications to be conducive and be suitable for any environment where we need to animate 3D objects. So let's start with what computer graphics is. What do you think is computer graphics? What do you think is computer graphics? Let's hear from Ashud. Is this your formal name, Ashud?
Yes, sir.
Yes, my brother. Can you help us? What do you think is computer graphics?
And that's not good technical thing to describe it.
All right, give me Chungonduza even in your vernacular language.
Graphics.
Yes.
I think the arrangement of pixels per screen or something.
Exactly. You have a very proper and good direction when it comes to computer graphics. Someone else to contribute. You know, I understand that you sometimes you want to go singatombozive chi, but the moment you're not going to computer graphics, the term computer you know it, the term graphics you know it.
Graphics.
Chingubatanidza katenza kuti muri kufunga chi. Yes. Arnold.
I think it is an art of drawing my lines, my pictures, my charts.
That's perfect. That's perfect. So that's the art. That's the art. It's an art of coming up with anything that is visual on a computer screen. So anything that is visual, or even we are specifying to say on the computer screen because that's the visual display unit that we use these days. But you may have a visual display unit that can work wirelessly or that can be displayed on any position on earth. So that art or that the mechanism that you work with to come up with those visual objects is what we'll be talking about in computer graphics. But with the current technologies that we have, we'll talk about the screens because these are the technologies. These are the objects that we are having in this era. So we will be talking about anything, even these words that you are seeing. They are part of screen visuals. You can visualize these things. You can visualize text. You can visualize images. You can visualize a full stop, a point. You can visualize anything that you can visualize or anything that you can say it exists in the world.
You are now muted.
Man. Can you still hear me? Can you hear me, guys? Let me share my screen. Big blue button did I say?
You are now unmuted.
Can you hear me, guys? I always think that we have ladies in the class, but it's so unfortunate that we only have gentlemen in here. Can you hear me? Nobody is available.
Yes,
Okay, I think I was having a challenge with the connection.
Okay.
But you can't see my screen, right?
We're seeing the screen.
You are still seeing it?
Yes.
that's fine. Okay, so I was talking about all the objects that can be seen on the screen. These are what you'll be talking about. How are they being projected to the screen, and where are they coming from? How are they being processed from raw information or from raw data up until it becomes an image, up until it becomes a colored text, up until it becomes a straight line, a curved line, a graph, a chart, or any kind of visual that we can see on the screen. So that is what we're going to talk about. So in other words, we have now defined what computer graphics is. We have now defined what computer graphics is, and from my understanding, computer graphics is just an art of drawing pictures, lines, charts, and by all these things, I'm just listing the items that we can have on the screen or on a visual display unit, and these things are pictures, lines, charts, but I have left a lot. The list is endless, and these can be projected on computer screen through the use of a computer programming language. So for this module we are going to use C programming for computer graphics. So in other words, computer graphics is a subfield of computer science which studies methods of digitally synthesizing and manipulating visual content. So we are just talking about the same thing, working with visual content, anything that is visual. Although the term often refers to the start of three-dimensional computer graphics, like what my brother said, he wants to learn animations. That's three-dimensional computer graphics. It also encompasses two-dimensional graphics and image processing. So before we look at 3D animations, we will look at 2D animations. But I won't take much. I won't go deeper when it comes to 2D. I will mainly focus on 3D animations or 3D computer graphics. And then we have two types of computer graphics. We have two types of computer graphics, and the first one is raster graphics, and then the second one is vector graphics. So raster graphics it's made up of tiny uniformly sized pixels which are arranged in a two-dimensional grid made up of columns and rows. So that's what exactly we are seeing here on the screen. That's exactly what you are seeing here on screen. So in other terms, raster graphics is also called bitmap graphics. So this is a type of digital image that uses tiny rectangular pixels or picture elements arranged in a grid formation to represent an image. So each dot on the screen, that's what we may call a pixel. That's a pixel. So these pixels, they are arranged in two-dimensional, in 2D. By 2D, we are just referring to rows and columns. We have rows and some columns. So if we want to refer to a certain dot on the screen, we define it by saying on row number 3 on column 4. So 3, 4, that's the point referring to this pixel. So that's raster graphics. And then we have vector graphics. Vector graphics is an image made up of paths or lines. That is, instead of having only one point referring to a certain point, we are now referring to 2 points. For instance, I said row number 3 and column number 4. That's 1 point. And then if we want to draw something, we may draw it using lines. And then we have another point, maybe 7, row number 7, column number 10. So we have a line joining these 2 points, and then with these points or with these lines we can formulate our images, we can formulate anything that we want to formulate with these lines. So vector graphics is based on path or lines to draw visual objects, and then raster graphics is based on pixels, that are points. So you can read more on these 2 types of computer graphics that we have here. So these are the kinds of computer graphics. These are the 2 kinds of graphics that you have. So in computer graphics, a vector graphic or vector image is an image made up of paths, that is lines with a starting and an ending point. These paths, they are all based on mathematical expressions. They consist of basic geometric shapes such as lines, polygons, and curves, and many more kinds of mathematical expressions that we may have. The key advantage of using vector graphics, you need to know this is very important. The key advantage of using vector graphics instead of raster is that vector graphics is scalable, and by scalable I mean you can change the size of an image without losing the quality of the image. So if you want to print it on an A4 page, you can as well print the same image on a very big, maybe on a poster without losing quality, without losing picture quality. But raster graphics is also good when you want to talk about when you want to project images with when you want to project images with more detail, like pictures with highly concentrated colors. Somebody is saying, say, besides talking, are you presenting anything? Yes, I'm having something. So that's why I was asking you, are you still seeing my screen?
You are now muted. You are now unmuted.
Right, I guess that everybody is back now. Are you all available now? Right, great. So this is what I was discussing with you. This is what I was saying. Screen share is ended. Something is happening here. Okay, it's okay. I think screen sharing is failing to work properly. So let me just upload my slide so that you can clearly see what I am talking about. Right, can you see now my slide? Right, so it's so unfortunate that my screen was failing to share. I don't know what's going on with the server here, but this is what we're talking about. So that's computer graphics. So that's computer graphics for you. And then I think we've talked about these 2 kinds. If you're asked about these 2 kinds, you can now tell. But the keynote is you need to know when to use raster graphics and when to use vector graphics. You need to know the advantages of raster graphics over vector graphics, and also advantages of vector graphics over raster graphics. By this I just mean to say you need to know the differences. You need to know where and when to use which kind of computer graphic. So I think I've made it clear for you on this one. Maybe if we get time, we'll talk more about this. But if we fail to have ample time to talk about this, then it means you have to do your research by yourselves. Computer graphics objects. Computer graphics images are represented as a collection of discrete picture elements, that is points or pixels. Points or pixels. Right, so pixels, I think I've talked about what a pixel is. A pixel is just pixels, it stands for picture element, and represents the smallest erasable part of a bitmapped graphic, maybe image, maybe line, maybe any kind of object that we can project on a screen. So graphics objects can be edited using keyboard, mouse, and touch sensitive panel on screen. So these, as we can observe, what we are now talking about, we are now talking about graphics objects, and these graphic objects, they are being processed for them to be projected well on the screen. So for them to be processed well on the screen, we need hardware components. And which hardware components do we need? And you need to know to say, if it's a keyboard, what will you use a keyboard to do, or what will you use a keyboard for in computer graphics? If it's a mouse, what will you use it for? And what kind of mouse is relevant for this kind of processing, responsible for high quality computer graphics? Touch sensitive panel on screen, how is this relevant to computer graphics? And its relevance is based on quality. So therefore you need to have graphic objects. For us to have graphic objects, we require graphic devices, which mainly include input devices and display devices. So these are the two main ones, but these cannot work, or we cannot have any computer graphics without data processing. And by data processing, mostly we will be processing what? The pixels or the points or the path, depending on the kind of computer graphics that you are working with. So are we still in the same bus? That's great. That's awesome. So graphics objects can be represented in 2D and 3D. So 2D and 3D objects can be manipulated through transformations. So transformations like what we did at O-level mathematics, where we've been talking about scaling, reflection, and other mathematical transformations that we used to work with. Those are the ones that we'll be talking about here for us to manipulate 2D and 3D objects. We can translate it, we can do all those things. So graphics objects can be animated in that. Graphics 3D building blocks. So these are the three basics or building blocks for animations: wave modeling, texture and materials, and then lighting. So these three, if you know these three, you are good to go. You can come up with Tom and Jerry, you can come up with wrangle, we can come up with any kind of animation that you wish to come up with. You can have anything that you wish to have. So these are the 3 building blocks. So we will learn modeling, we will learn texturing and applying materials or manipulating materials, and then we will learn lighting. That is, if we have our scene, we will learn how to put some dark areas in our scene, so to add more light on some other parts of the scene. So these are the 3 building blocks of 3D graphics. So if you are highly interested in these things, you better start your research on these things, so that when we start implementing it, it becomes so easy for you to follow. Then it is an art of drawing lines and all that's computer graphics. OpenGL programming, that's one main issue that we'll be talking about. OpenGL programming. Output primitives, 2-dimensional clipping, polygon filling, all these we are now working with programming. Like what we said in the definition, it is an art of drawing these things using a computer programming language. So we will use OpenGL but using C programming, implementing OpenGL using C programming language. So we will do all these things: output primitives, 2-dimensional clipping, polygon filling, all these things using C programming, OpenGL. So for computer graphics, those are the main topics to be covered. And then we have multimedia. Can somebody define what multimedia is? What you just think by multimedia? What is multimedia? Siband, tell us. What do you think is multimedia? Arnold is already unmuted himself to say something. Can you say something, Arnold?
Okay, it is the use of computers to present and combine my text, my audios and videos.
Yes, from the term multi. Thank you very much, my brother. You have done a very good job. When we say multi, it means many. Then media, we are referring to anything that can be used to communicate or to convey a message. So multimedia is combining all forms of communication media that we can have. For example, we have text, we have what, we have images, we have what, we have sound, we have what, we have many kinds of media that we can use to communicate. So multimedia is just a combination of all these things. So it's just the use of formal definition. Multimedia is the use of a computer to represent and combine text, graphics, audio, and video with links and tools that let the user navigate, interact, create, and communicate. So that's multimedia. And then we have multimedia authoring. Multimedia authoring is now combining all kinds of media together and let them be capable or be able to represent multimedia on a computer screen or using a computer. So multimedia authoring involves collating, structuring, and representing information in the form of a digital multimedia, which can incorporate text, audio, moving images, still images, and so forth and so forth. And then we have features of multimedia authoring tools. We have editing and organizing features, programming features, interactive features, performance timing and playback features, cross-platform and internet features. So these are the common features of multimedia authoring tools. So our main aim on multimedia authoring tools is to come up with an authoring tool, a multimedia authoring tool, or to manipulate an existing multimedia authoring tool. That's our main aim on multimedia. That's why we have computer graphics and multimedia. So on multimedia part, we are mainly focusing on coming up with multimedia authoring tools or manipulating existing multimedia authoring tools so that they become, or they allow end users to display high quality multimedia content. So when you come up with your own multimedia authoring tool, you need to make sure that these common features are available on your application. Can you give me examples of multimedia authoring tools? Can you give me examples of multimedia authoring tools that you know? Wayne, wanyanyunyararisa shama chimbotitipirawa
Blank is
blankere baba
blank.
I should story ratings.
This is answer was here.
Also mugeta
And I told you.
mdara muwana zeri mimi mdare mimi komunashi taura tinzwe kamunashe shama vanhu vari kutadza ava varatidze kuti iwewe ndiwe mbinga dzemultimedia. munashe taura tinzwe shama. My examples a multimedia authoring tools. Vanokudibirwa mana. Vanokudibirwa. All right. Can you give me an example of a multimedia content? Multimedia content. Tombota iyi ndo yatoti multimedia iyi. Wakaitarisa so uchingotarisa so but this is multimedia. An example, I'm observing that I have DVD. I need more examples. I need more examples. Right. I want to give you a hint, and I'm giving you this hint in this way. Perfect Munashe there. Perfect is coming up with many examples and they are all correct, but let me give you this example so that you don't claim these examples. You need to know these examples. Number one, we are saying multimedia. So with multimedia, what do we have? We have text, we have image, we have moving images, we have sound. So whenever you have image and sound, the content that is having image and sound is what? Is multimedia content. The content that is having moving image with some text, that's a multimedia content. So haven't you made some flyers? That's a multimedia content. And here we are having what? Sound and some text there. Is this not multimedia content? So give me some examples of multimedia content, please. I think I've given you some hints. Multimedia content. Amana panda ndambozama kureritsiraya. Terirai Aston Sibanda. Semunamboti bude kadzoka so. Pongongoenda ku smoking break. Two agents of man. Right, Arnold Abiri is giving me perfect example. E-learning. Mana no get man. Mana no get. That's good. What else? What else? What else? What else? Tunati tidzige kusvika tasvika pamongo wechinese. Cloud. Yes, cloud. Munoona maexamples amuri kundipaya kaya akanakisa, but by the end of the lecture mwafanira kunzwisisa zvokuti pamunondipa next time you give me molded and panel beated examples which are perfect, so esa muri kundipa ndikuwaona. We'll talk about all those examples. Ndipei my examples. I think anenge ati one day yane guka makafela icho. Akomana ndine mageto yuti munomu. Alright, that's fine. Sekutaura kwatamboita kuti multimedia is having text, videos, images and so forth. So examples of multimedia content ndakupai ndikati maflyers, ndikakupai ndikati mavideos, because video iri kucombine image, iri kucombine. Sometimes you can find anonzi machikwa ekuti unonge video inenge ichiplaya ichibudisa futi zviri kutaurwa. What's the name of this? Subtitles. Thank you very much, Ashwood. No, that's multimedia. Saka, now when we are saying authoring tools, authoring nanti kunyora ndi author ka. Tikati author ndiana kanyora this book. Tukutu who is the author? Who authored this book? And Saka, which tools do you use to make videos? Those are the authoring tools. Which tools do you use to come up with a poster? Which tools do you use to come up with this cloud application? Which tools do you use to come up? I think answers are now popping in your mind. We have cameras there. Yes, camera is good, but camera is a hardware, is a computer graphics hardware device, not an authoring tool as such. But I like it because you are coming from low level of computers. That is, you are coming from hardware up until you get to Photoshop, Lightroom, Adobe, After Effects, and so forth and so forth. So you now observe that the examples are now coming out of your mind. It's now coming out from your mind. You are now giving me correct examples. So you now understand multimedia and authoring tools. So your main objective now is to come up with such an application like Adobe Photoshop, Lightroom, After Effects, and so forth and so forth. Or it's just a way of manipulating Photoshop so that it edits or it adds more features to the end users who edit pictures. So your job is not to understand Adobe Photoshop for removing background and adding whatever nonsense that you want to add onto the background of an image, but your job is to add the functionality to that Photoshop in such a way that when you edit the background, the users will benefit from the features that you have added. So that's our job in this module. That's our job in this module. And PowerPoint is one of the authoring tools that we have. We also have Microsoft Word. I just think the Microsoft Office package is filled with authoring tools. So, but they are just low level. They are not high quality authoring tools. You can program using multimedia, using PowerPoint, using Word, using Excel, using all these, but they don't give you high quality multimedia content like what we can get from Lightroom, from Maya, from After Effects, from all these applications that we can get. So that's what we have. And then types of authoring tools. We have card and page based tools, icon based, event, time based. I'm giving you this as a takeaway so that you go and look at these types and their differences and so forth and so forth. So this is your takeaway number one. Go and look at these three types of authoring tools: card and page based authoring tools, icon based, and nonsense. So that's what we have. If I may give you some hints, card and page based tools. These two provides a simple and easily understandable metaphor for organizing multimedia elements. By multimedia elements, we are referring to text, audio, video, images, and all kinds of media objects that you can have on any platform. It contains media objects such as buttons, text, files, graphic objects, and so forth and so forth. It provides facilities for linking objects to pages or cards from the term card and page based. So it focuses on cards and pages. So the software required is HyperCard and Linked Card Toolbox. HyperCard and Linked Card Toolbox. And then we have icon based. You can observe you can get the meaning from the term itself. Icon. What are icons? It's based on icons. So what are icons? So it's icon based event driven tools. So icons or object based tools are the simplest event driven authoring tool. Its provision of simple branching is the ability to go to another section of multimedia production. So multimedia elements and interaction are organized in the flowchart. So the flowchart can be built by dragging appropriate icons from a library and then dropping it, like if you have programmed in Java using NetBeans, or if you have programmed in Visual Basic.net, you can do what? You can what? It's what? And drag and drop. You can drag objects and drop them onto the screen or onto the form. So that's icon based. You can come up with an interface with buttons like what we have on when we go to TM or OK, or the point of sale application. It's icon based, event driven too. So that's what we have on this. I'm leaving this for you to delve and get more on your own. And then we have time-based tools. So time-based tools, you can get confused to say you are saying time-based tool. Before you talked about card and page, you can understand that we have a card, we have a page, and then later on we talked about icon-based. We have icons, we understand icons. But now time, what do you think is a definition of time-based tools? Can you give me your suggestions or what you think about time-based tools? Let's talk about this and close for the day. I don't want this to last too long so that you don't get bored with these things. Yes, let's talk. Asina mbotaura ndiani mama. Let me just check tataura kashoma ndiani banampika iye. It's our biggest concern, the pushing factor. Time is the major element. Yes. All right, that's fine. So by time, tungotaura kuti ma objects edu are timed. Kana iri picture iri kubuda is timed kuti iri kubuda for how many seconds? Have you ever observed kuti, all right, let me take you back to your early ages. Pamwe muchiri grade 3 kana kuti 1 or maybe earlier than that. ukatora kamoto katanga katenderedza, so it looks like you are drawing a zero or you are drawing something. It's all about time, but there's no zero, but it's all about time. You are moving it as fast as possible. Within 1 second you have moved it. The fire point has reached several points at a time, and the rate at which your eye is viewing these points is slower, and you can see as if it's one object, of which it's not an object, it's just one point that is moving as fast as possible. So it's time based. It's all about controlling the time that our objects are appearing on the screen. So you go deeper by yourselves. You go deeper by yourselves. And I think this is the end of our first lecture, which is just an introductory lecture. Let me check if I have. If I have uploaded assignments. I haven't uploaded anything on the virtual learning environment, that is the portal, but maybe by the end of the day I will post something. Right, thank you very much for the day, for being with me today this hour. Please enjoy the rest of your day. Goodbye, gentlemen. Hapana namsikana kam class muno. Anonzani musikane ndeupi atisimbomuona, sei ari kurova kumclass. Ari kurova muna. Vimbai ari kupansi muona. Alright. Anyway, mume encourage kuti attend these lectures because anosaririra tikazoshaya kuti toita sena. Right. So that's it. Goodbye. Enjoy the rest of your day.